Hello, today we're going to be talking about pressure and Dalton's law, so please label your notes with today's date and title them Pressure and Dalton's Law. We'll start by talking about pressure. What is it? Well, first we're going to review gas properties. So think back to the different states of matter. How do particles behave in a gaseous state? Think about it for a minute. Well, what we know is they move around very fast. They have the most kinetic energy, and the different molecules will be bumping into each other. So, two important qualities about gases is that they assume the shape and volume of their container. We've been talking about this all year. And then also they have lower density than solids and liquids, and that's why the gas is all around us versus just staying at the bottom, like towards the ground. One way to define pressure is force per unit. Make sure that you've written down the properties of gases and then you write down that the definition for pressure is force per unit. Which of these pictures shows more pressure on the bottom of the foot? Why? Well, this is a tricky question, kind of a trick question. So even though the elephant has a lot more pressure overall, the elephant has 4 big feet that the pressure is dispersed on versus this person right here is wearing high heels, so the pressure is being dispersed on just a little part of her foot. So honestly, the pressure is probably about the same because there's the same amount of pressure per unit area. So this is why dull knives are actually more dangerous than sharp knives because in order to cut through something, it needs a certain amount of pressure. So you suddenly have to have more force for that greater area, because if a knife is dull, there's less sharpness to it. So you have a greater area that you're cutting with. So you have to apply more pressure into it, which is why you actually have more injuries with dull knives. Chemists think of pressure in terms of the movement of molecules. So again, review in case you haven't written it down yet. Pressure is how hard and how often molecules are hitting each other, are hitting other molecules. It is force per unit. So here we see this picture of each time a molecule hits another molecule, it's providing pressure in this balloon, which causes the balloon to stay afloat, stay filled up. So an example that we can look at the units is bike pressure. A bike tire pressure, normal pressure would be 70 psi. Well, psi stands for pounds per square inch. How might this demonstrate force per area? Pause the video and write down how might the unit force per area, the pounds per square inch unit, demonstrate force per area if we're talking about the definition of pressure. Write that down. We'll talk about this in class. Next, we're going to talk about atmospheric pressure. The Earth's atmosphere is composed of a mixture of different gases. The next slide will talk about those different gases. And each molecule of gas in the atmosphere is held to the rotating Earth by gravity. There's a column of air sitting on top of your head that extends all the way out into space that is exerting pressure on you. You do not need to write this slide down. So what is air? 2 gases make up most of the air around us. What are those 2 gases? Look at this diagram, this chart over here. Well, we see the air around us is mostly made out of nitrogen and oxygen, and then a bunch of different other gases that make up the remaining 1%. We see all of these examples here. There's also other gases that aren't listed that create some odors around us. And this is the composition of just dry air. 99% of the atmosphere is in bottom 19 miles above the Earth's crust. Molecules at the top of the atmosphere exert pressure on the molecules below, creating the most pressure at the surfaces of the Earth. So this is why you might talk about altitude sickness if people go up higher because of the different changes in pressure. Then standard or average sea level pressure is 14.7 pounds per square inch. Units of pressure. So again, pressure is how often and how hard molecules collide with the surface. So look at these units now. and talk about how do these demonstrate force per area. We also have ATM, mmHg, kPa, torr, psi, and these all will demonstrate force per area once you look at what they mean, but you do not need to answer this in your notes. So think back to temperature, what we learned about last video. So temperature is the measure of average kinetic energy of molecules, and we measure it in degrees Celsius or Kelvin in chemistry. We can sense temperature, but what does this mean in molecular terms? We actually, there's different pressures in the temperatures depending on the temperature, because of course temperature, the higher the temperature, the more kinetic energy there is moving around. So hot air is moving really fast, creating more pressure because the molecules are hitting, are knocking into each other more and more. So make sure you write this down, how temperature relates to pressure. Temperature, higher temperatures, hot air is moving around faster, colder temperature has less kinetic energy. So again, colder temperatures also hit each other less, the molecules hit each other less than in hot air. Now label this section of your notes Dalton's law. Dalton's law states that gases mix homogeneously. Our atmosphere is a combination of gases, like we talked about previously, but together they exert pressure. So if the overall atmospheric pressure is 1 atm, then the pressure of just the nitrogen in the air is 0.78 atm, and the pressure of the oxygen in the air is 0.21 atm because it's divided out. Dalton's law of partial pressure states that the total pressure of a mixture of gases is equal to the sum of all the partial pressures of the components of gases. Write down this definition. Write down this equation too. So we see in this image right here that the pressure of this container and the pressure of this container, if you combine them together, will equal the pressure of this container because you're adding those molecules all together. An example that we're going to go through that you'll have to be able to do an example just like this is if a metal tank contains 3 gases, oxygen, helium, and nitrogen, then what would, if we see that the oxygen takes up 35 atm or exerts 35 atm pressure, the nitrogen 5 atm, and the helium 25 atm, what is the total pressure inside of the tank? Well, we're just going to use this equation here and do 35 plus 5 plus 25 atm equals 65 atm. Very clear, very easy equation to use there. So you can continue on with these practice questions. So pause the video and answer these 5 questions. This first question asks you to look for 3 things around your house, or say your garage, or in the street if it's safe, that lists a pressure unit and lists the objects in the unit. So I already gave you one example, a bike. So don't use a bike, but you could look at other things around your house that might have pressure valves. If you need help, you could even use Google if you can't find things around your house, but find 3 common objects that tell you a pressure, and then list the object that you found and the unit of pressure. And then you have a few other questions, some math questions. Make sure that if the question asks you to explain it, make sure you explain your answer. And if you have any questions on these practice questions, make sure to email your teacher or bring your questions to the next class. Thank you.